Here's June 2015, numbers 29 to 32. Dylan invested $600 in a savings account at a 1.6% annual interest rate. He made no deposits or withdrawals on the account for 2 years. The interest was compounded annually. Find to the nearest cent the balance in the account after 2 years. So, if we look here, if Dylan's putting money in a savings account and he's gradually getting more and more money, it's because is exponentially increasing. And if you remember your exponential growth formula, I should say, it looks like this. Y equals C, parentheses 1 plus R to the power of T. Okay, where C is your starting value, Y is your final value, what you're solving for, R is your rate, and it's always as a decimal, and T is your time. So, if Dylan is investing $600 into this account, he's going to start with $600. So Y equals 600 times 1 plus, now the R value, 1.6 is a percentage, and we need to change that to a decimal by dividing by 100. So that converts to 0.016. We're going to raise it to the time, and we're talking about 2 years. We could type all of this into our calculator at once. Be sure to use parentheses, and you'll end up with Y equals $619.35. So this is the money that Dylan will have in his account after 2 years. Number 30, determine the smallest integer that makes the following inequality true. Okay, so we need to solve for x. And we have negative 3x and a negative 5x on the same side of the inequality, so we can combine like terms and get negative 8x plus 7 is less than 15. To get x alone, I'm going to subtract 7 from both sides. I'll end up with a negative 8x is less than 8. Going to divide by negative 8. And I'll end up with x is, now be careful, we are going to flip the inequality because we divided by a negative. Okay? So this is important. Every time you divide or multiply by a negative, when you're dealing with inequalities, you have to flip that inequality. So x is greater than negative 1. Now they asked us, what is the smallest integer? So if you just leave it like this, you won't get full credit. You'll get 1 point out of 2. Now if you needed to make a picture to see it, here's what your picture would be. Negative 1, 0, 1. So at negative 1, it would be an open circle because it's not equal to negative 1. And if you remember, greater than, and look how it's pointing to the right. And you can only do this directional pointing method when x is on the left. You always want your x to the left of the inequality. So this is the way that your graph will be pointing, right? It's greater than, which means the smallest integer in your solution is not negative 1 because it's not equal to negative 1, it's actually 0. So what you would have to say is that 0 is the smallest integer. That is your answer. Number 31, the residual plots from 2 different sets of bivariate data are graphed below. Remember, bivariate is 2 things of data that are being compared. And explain, using evidence from graph A and graph B, which graph indicates that the model for the data is a good fit. Okay, so with residuals, it's almost like a backwards way of thinking. So because there is no pattern in graph A, it is a better line. So you're going to say that the model for the data that is the best fit is graph A because there is no pattern. This is only true when you're talking about residuals. Number 32. A landscaper is creating a rectangular flower bed such that the width is half of the length. Okay, so the area of the flower bed is 34 square feet. Write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. Well, we're going to be dealing with length, so we're going to have our let statements. Let L equal the length. Let W equal the width. And our first formula says the width is half of the length. So that means W turns into equals, and we're going to have 1/2 of the length L. First formula is done. Second formula, we have the area of the flower bed. Well, you remember the area is length times width. So the area of the flower bed is 34 square feet. So 34 is going to equal our length times our width. Write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. What we need to do is use substitution method and take this 1/2 L and substitute it into our other formula for W. So what we'll have is L times 1/2 L equals 34. Okay, so we have 1/2 L squared equals 34. Okay, I'm going to subtract 34 from both sides to get this to be 1/2 L squared minus 34 equals 0. Okay, so what I can now do is use the quadratic formula. And the quadratic formula says that in this case, L, right? You're used to seeing X, but because we don't have an X, we're talking about an L. So L is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So our a in this problem is 1/2, our b is 0, our c is negative 34. So if I plug that in, I'll end up with L equals 0 plus or minus the square root of 0 squared minus 4 times 1/2 times negative 34 all over 2 times 1/2. I'll end up with L equals plus or minus the square root of 68, and 2 times 1/2 is just 1, so L will equal a positive, and if I round to the nearest tenth for the length, I get a positive 8.2. Or the other option is negative 8.2, which I will reject because we're talking about length, and you can't have a negative length. So we get our length, but we're not done because they're asking for the width. So to find the width, I can plug it back into the formula 1/2 times L, so half of 8.2 will equal my width, and I'll write it over here. My width should equal 4.1, and we're talking about feet. So 4.1 feet is the width, and that's your final answer.